Hello students, welcome back to my channel. In this video, we will be continuing the topic of physical topologies. In the previous video, we studied what is a topology and what is a mesh topology to begin with. Now, we will be studying two other topologies in this video, which is the star topology and the bus topology. Now, starting with the star topology, the biggest difference between the star and the mesh topology is that the star topology contains a central authority or a central controlling device which is known as a hub. Now we will study in detail about the hub, switch, bridge, routers in future videos also, but till now you must only understand that apart from the devices that form the network, the star topology consists of a central device like this, which is known as the hub. So another difference is that every device in a star topology will have a dedicated point-to-point link only with the hub. No devices will be connected with each other directly. Okay, so no direct links between any two pair of devices. Any two devices will not be connected directly, and if they are not connected directly, no direct exchange of traffic between devices will take place. And in that case, if a device A wants to send data to device B, then what will be the order in which this communication will take place? A will send the data to the hub, and then hub will send the data to B. So this is the diagram of a star topology that I have shown here. As you can see, this topology consists of a central authority, which is the hub, and these are the four devices A, B, C, D that are connected to it. Now, if A wants to send some information or to communicate with C, then A will first send its data to the hub, and then hub will send that data to the destination device, which is C in this case. Now you have seen that the star topology is very much different from the mesh topology. So now let's see what are the advantages. So every time you study a topic, you must think and you must try to find out why did this concept actually came into being. Why was there a need to make star topology if we already had a mesh topology? So that is why you must know what are the advantages of this topology over the existing mesh topology. So starting with the first advantage, this star topology definitely requires a lot less cabling or lot less hardware resources as compared to mesh topology, because each device has to have only a single connection, and that connection will go to the hub. The devices need not be connected to each other. So this reduces the amount of cabling, and therefore this topology becomes less expensive. Also, it is very easy to install all these devices. You just need a central a controller, which is the hub, and a single wire, the physical medium that will be connecting the device to the entire network. Okay. Now, scalability is also a very important advantage here. And what do we mean by scalability? Scalability basically means that addition of a new device or even deletion of a device existing in the network is very easy, because if a new device has to be added, uh, just a minute, addition and deletion of devices is easy. So now if any new device has to be added, we just need to connect that device using a single communication physical media to the hub, and removal of that device also will require removing a single connection. And this scalability is an easy process because the other devices, the remaining configuration of the network, the remaining structure is not getting affected in any way. Now, with its advantages, there comes a disadvantage of the star topology, and the biggest disadvantage of this topology is that if the hub goes down, everything ends. Okay, so if the hub stops working, the entire network goes down, because it is through the hub that the entire communication between all the other devices is taking place. So we can say that the hub is a single point of failure. This is a single point where if a failure occurs, the entire network will come to a halt. No communication will take place if the hub stops working. So basically, having a central authority gives you advantages, but at the same time, complete dependency on this central authority, the central controller, the hub, will make you it will make the topology very risky in case that the hub stops working. Okay, now let's come to the third kind of topology, which is the bus topology. Now, as you can see in the bus topology, in the diagram that I've drawn here, there is no central authority, neither the devices are connected to each other. So what is actually a bus topology? It consists of multi-point connections. So both the topologies, the mesh and the star topology, consisted of point-to-point connections. Okay, whether those connections were between the devices in mesh topology or between the hub and the device in star topology. But in this case, there are multi-point connections. That means this bus topology will contain of a single main cable. This is the main cable that is running through, and to this main cable all the other devices of the network will be connected. So in the bus topology, there is one single cable that links all the devices, and this cable is also known as the backbone of this network. Okay, so the bus topology again has a central point where everything is connected. So you can guess that one disadvantage of this topology would be single point of failure. So we will discuss this in a few minutes, but now you must also remember that each of the links that connect the devices to the main cable are known as drop lines. Okay, and drop lines are connected to the main cable through something known as taps. So this is how the connections take place in a bus topology. Another important point is that when signals or when data is transmitted through the main cable, then as it travels towards the other end of the cable, the signal will become weak because some amount of energy is lost in the form of heat. Okay, and this signal will again then need to be repeated. So signals become weak, and it puts a restriction on the number of devices that can be connected to the main cable, or the length of the cable that you can spread out. Okay, so this is an important point. Again, it will lead to one of the disadvantages, but for now, note this down, that signals traveling across the main cable become weaker as they progress. That means as they move from one location towards the end of the cable. So if any device has to communicate with any other device, what will happen is, if A has to send data to D, it will send the data, the signals, through this drop line connecting A to the main cable. Then this data will travel on the main cable and it will then be received by D. If the data is also getting received by the intermediary devices, they will check whether the destination is actually their own address. That means if the data is actually intended for them, if they are supposed to be the destination of this data, then they will receive it. Otherwise, they will forward it through the main cable ahead. Now, since signals are traveling across the main cable and they tend to become weak, so it puts a restriction on the number of devices that can be connected to the main cable. Puts a restriction on the number of devices that can be connected. Okay. So coming to the advantages and disadvantages of this bus topology. Starting with the advantages, definitely this topology also requires less amount of cabling as compared to other two topologies. And why lesser amount of cabling is required? See, in the case of mesh topology, each device had to be connected to every other device. So those connections, those cabling requirements are now eliminated. And in the case of star topology, every device had to have a cable that was going all the way till the hub. Okay, but in this case, every device can have the shortest link that connects it to the main cable. Okay, and we can lay down the main cable in bus topology in such a location or in such a way that it connects to the devices in a very using a very small or a comparatively smaller length of cable. Okay, now since the amount of cabling is less, so there is ease of installation. Only the device that needs to be installed has to have a single connecting wire to the main cable, and the cost is also reduced. Okay, to some extent cost is less because the cabling is less. Coming to the disadvantages, it is difficult to reconnect or establish new connections with the existing cable. So basically, when the main cable is laid out, it is assumed that approximately these many devices will be connected to this cable, and this is the strength of signal that will be supported in this transmission using the bus topology. But if one of the if some new devices have to be added, then it becomes a problem. Okay, and it leads to scalability issues. Also, there is a fault identification becomes difficult because there is a single running cable, and if any kind of problem occurs in a communication, it is very difficult to find out where exactly in the cable or which link is actually giving the problem. Now the last is, again, there is a single point of failure where the entire network can be brought down, and that is the main cable. If the main cable has some physical issues, it gets worn off, it is affected by environmental factor, then this entire topology will stop working. Okay, so that's all for today's lecture. In the next video, we will be studying about the hybrid topology and the ring topology. So stay tuned to our channel. Thank you for watching. Till we meet in the next video. Mind your exam.